We're looking at limits of rational functions. That's right, rational functions. Rational functions, they look like fractions, right? It's a polynomial on the top, a polynomial on the bottom, and we are looking at limits to infinity. And we need to remember how large infinity is. Your understanding of infinity is how you understand these problems right here. Remember, infinity is unreachable. Infinity is larger than you can ever imagine. It is every single dollar in the world, but more. It's just this unreachable, unattainable, vast amount. So hopefully as we look through these, we realize not just how to use infinity, but we get a better idea of how to use infinity too. So this first one right here, we have the limit as x approaches infinity, 4x plus 5 over 8x minus 3. Now, in the world of infinity, as x is approaching infinity, so we're putting an infinity in for x, right? Think direct substitution here. 4 times x, 4 infinities. 4 times infinity, 4 infinities plus 5. Remember how crazy large infinity is. All the space, all of the amount, just imagine an infinite amount of something, and then someone says, okay, and then we're going to add 5. But there's already infinity of them. So why does that 5 matter at all? Well, it doesn't matter very much. Down here on the bottom, 8 infinities. 8 times infinity. And then we're going to subtract 3. But I already have infinity. So why does that minus 3 matter very much? And that's true. Compared to infinity, this plus 5 and this minus 3 are insignificant. And hear me on that. These guys right here are nothing compared to infinity. And it's not just infinity, it's 4 infinities, it's 8 infinity. And so once we get rid of those insignificant pieces right there, we have the limit as x approaches infinity of 4x over 8x. And that rational function right there, that can simplify. You can cancel out those x's, and we get 4 over 8. Four over 8 reduces to a half. And the limit as x approaches anything of a constant, 1/2 is just a constant. It's going to be a constant. It's going to be that constant right there. So it's 1/2. So remember, the limit as x approaches anything of a constant is going to be that constant. So we were able to eliminate the insignificant pieces. We're able to simplify what's left over, and then once we simplify what's left over, we have our answer. And that's only because x is approaching infinity. If x wasn't approaching infinity, then our whole argument really just unravels, and it's not very helpful. Okay, let's continue to think about it this way. But let's look at x approaches negative infinity. It's still infinity, it's just a negative version of it. 6x squared minus x, 3x cubed plus 1. All right, so now we are on the top. We have x, which again, we're substituting in infinity because x is approaching a negative infinity. Negative infinity squared. I mean, just imagine negative infinity being squared. Infinity, because a negative times a negative is just a positive. So we have infinity squared. Infinity times infinity. That's infinite infinities. Times 6. That times 6. Okay, we have 6 infinite infinities minus an infinity. Minus infinity. I already have infinite infinities. So this minus infinity doesn't matter very much. Let's keep our colors the same as before. that minus infinity doesn't matter compared to 6 infinite infinities, right? On the bottom, we've got 3 times infinity cubed, an infinite number of infinite infinities. And it's negative infinity. That just means it's all overall going to be a negative answer. But infinity times infinity times infinity, an infinite number of infinitely many infinities, plus 1. Plus 1 what? Just one number? Not even an infinity? It's just a 1? Now that's insignificant compared to everything else. Whew. Jeez. This is crazy stuff. So on the top we have 6x squared over 3x cubed. And now we can do some simplifying. On the top and the bottom, there's some x's. Cancel out. 2 x's on the top with 2 x's on the bottom, leaving us with 6 over 3x. The 6 over 3 also can simplify. We have 2 over x. All right, now let's think. Let's think about this. On the bottom, x on the bottom. There are no x's on the top. So we have a negative, if we think about x approaching negative infinity, on the bottom, we are getting closer and closer to negative infinity. That value is getting really, 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 really large. Yes, it's negative overall. Okay, well, we can think about this being overall some kind of negative value, but we're dividing by some gigantically vast number. Its value is negative, but it's also really, 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 really huge. And when you divide 2 by something larger and larger and larger and larger, those values are getting closer and closer and closer to 0. Remember your parent function 1 over x. All right, remember this parent function. Well, to sketch it really quick, it would look something like this. Well, all that's happened here is we had a vertical stretch by 2. We've multiplied it by 2. And if we stretch it by 2, all that really changes, I'll do it in green since it's in green right there. All that really changes is it would just be stretched a little bit. This. And notice as we approach negative infinity, these values are getting closer and closer to 0. So the graph tells us the same thing. As we approach negative infinity, our outputs are getting closer and closer to 0 because there is a horizontal asymptote, y equals 0. It's all coming full circle. If you can picture the graph in your head, that's great, but we also want to understand what that infinity is doing for us. All right, let's move on to this last one here. The limit as x approaches infinity, 5x to the 4th over 9x cubed plus 2x. All right, now we know the deal. We know the situation. We know how infinity is pretty crazy. So we, at this point, can see infinity to the 4th power, infinity cubed, and then we just have 2x. So this is insignificant compared to everything else. Limit as x approaches infinity, 5x to the 4th over 9x cubed. Simplify what we have left. What we have left over, 5x over 9, it might help you to write it like this. This is a polynomial. This is now the x is not on the bottom of our function. The x, we have 5/9 x. This is linear. This is a linear, this is a line that would have a y-intercept of 0. Oh, no. Oops. There we go. This is a line that would have a y-intercept at 0 and has a slope of 5/9. This is just a polynomial. And a polynomial we know we can treat with the leading term test, or you could graph this out really quick. We know the slope is positive, so it's going to look something like this. And the limit as x approaches positive infinity. Looking at the right side of this graph, this is approaching positive infinity, which is unbounded. Therefore, our limit technically does not exist. But the positive infinity is important. It gives us direction. Okay, so it's all going back to our limits to infinity polynomials. All right, big stuff here. Hopefully this helps understand infinity just a little bit more. And if it doesn't, then look for some other resources on infinity. Man, it is important, crazy, big stuff.